previous lessons, we have analyzed the steps of a calibration, and we have seen that in the first step it is necessary to have a measurement standard available. In principle, measurement standards are kept at the primary metrological institutes of each country and are extremely complex and expensive pieces of equipment, as one can easily imagine. It is therefore not feasible to think that the primary standard could be used to calibrate all the instruments in a country for obvious reasons of time, first and foremost, as well as cost, and to preserve a highly valuable piece of equipment. Therefore, the primary standards are used to calibrate a number of high-quality instruments within the same metrological institute. These instruments are used to calibrate the reference instruments of other calibration laboratories, which in turn are used to calibrate the reference instruments of industrial laboratories or other activities, for example in the clinical field. Finally, these latter instruments are used to calibrate the instruments employed in the field. In this way, a hierarchical pyramid structure is created in which each level transfers metrological traceability to the next level. This gives rise to what the VIM calls a calibration hierarchy, which it defines in Article 2.40 as a sequence of calibrations from a reference to the final measuring system, where the outcome of each calibration depends on the outcome of the previous calibration. There is an important point in this definition. The outcome of each calibration depends on the outcome of the previous calibration. When we discussed the calibration and calibration uncertainty, we saw that the uncertainty attributed to an instrument following calibration is always greater, at least in principle, than that assessed before calibrating it, unless the uncertainty of the standard is negligible compared to the latter. What we have seen entails as a natural consequence that measurement uncertainty necessarily increases along the chain of calibrations. It is therefore possible to state that the instruments at the lowest level of the hierarchy have been calibrated with reference to the national standard if and only if all the instruments at the higher levels of the hierarchy have been calibrated by instruments which in turn are calibrated with reference to the national standard. We can better understand what I have just told you by representing it graphically. Here we see that the higher levels serve as a reference for the lower ones. That is, the latter regard the instruments at these levels as measurement standards. In the same way, we see that the lower levels take their reference from the higher ones. That is, they regard the instruments at these levels as measurement standards to be used for their own calibration. This property of a measurement result being able to be traced back to a national standard, even if the instrument producing it has not been calibrated by direct comparison with the standard, but through a hierarchy of calibrations, as we have seen, is called metrological traceability. The VIM defines it in Article 2.41 as property of a measurement result, whereby the result can be related to a reference through a documented unbroken chain of calibrations, each contributing to the measurement uncertainty. The documented unbroken chain of calibrations referred to in this definition consists of a hierarchy of calibrations like the one we have seen, which is unbroken if, as mentioned, each level refers through the level immediately above it to the national standard. In fact, the VIM itself, in a note to the definition we have just seen, reminds us that metrological traceability implies the existence of a calibration hierarchy. In a subsequent note, the VIM also adds that for measurements with more than one input quantity in the measurement model, each of the input quantity values should itself be metrologically traceable, and the calibration hierarchy involved may form a branched structure or a network. The effort involved in establishing metrological traceability for each input quantity value should be commensurate with its relative contribution to the measurement result. This last point is important and refers to the uncertainty propagation law that we saw in a previous lesson. If you remember, the uncertainty associated with each input quantity is weighted by the partial derivative of the function that links the quantity to be measured to those actually measured, and the product of the weight and the uncertainty provides the contribution to the combined standard uncertainty. The greater this contribution, the more effort must be made to reduce the uncertainty by choosing suitable standards for the calibration of that quantity. The definition of metrological traceability contains another important point. The calibration chain, as well as being unbroken, must also be documented. The VIM, in another note to the definition we have seen, explains its meaning, establishing that the measurement uncertainty must be documented, that the measurement procedures used must be documented, and that the technical competence of those carrying out the measurements must be accredited. This means that through these documents it is possible to ensure that measurements are carried out by competent operators according to established procedures, and it is possible to verify that the procedures themselves and the methods used to assess uncertainty are metrologically correct. Now, pay attention to a point. As the VIM states in another note, the metrological traceability of a measurement result does not ensure that the measurement uncertainty is adequate for the given purpose or that there is an absence of mistakes. In other words, a preliminary analysis is always necessary to understand what measurement uncertainty, known as the target uncertainty, is required for the intended purpose. Subsequently, one can choose the calibration laboratory that guarantees, through its metrological capabilities, not only traceability but also an uncertainty level suitable for one's needs. The metrological capabilities of a laboratory are referred to by the term calibration and measurement capability, abbreviated as CMC. To summarize, we have seen how it is possible to access primary standards indirectly through appropriate calibration hierarchies, which, by ensuring an unbroken and documented chain of calibrations, can also guarantee the metrological traceability of a measurement result. We will see in a future lesson that metrological traceability can be ensured by an adequate accreditation structure.